Okay, let's take a run through a couple of examples. We're going to start off with doing a cross product with two-dimensional vectors. So you can see A here is minus 2i plus 4j, so strictly in the xy plane, and B is 3i plus 1/2 j, again strictly in the xy plane. So A is equal to minus 2i plus 4j, and B is equal to 3i plus 1/2 j. And we want to have A cross B. So I'm going to use the determinant method for this, just so you get some practice with the determinant method. And so A cross B is equal to I, j, k, minus 2, 4, 0, 3, 1/2, 0. And the straight bars show me that this is a determinant. I'm going to start off with the I hat. I cross out the column and the row that I is in, and I'm left with 4, 0, 1/2, 0. That's a 2 by 2 determinant. Then I'm going to do j hat, but j is negative. Again, the way I know that, if I have a 3 by 3 determinant, the upper left is positive, and then you alternate negative, positive, negative, positive, negative, positive, negative, positive. And just so you know, if I had, say, a 4 by 4, it's positive is always in the upper left-hand corner, negative, positive, 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 negative. You just alternate as you go left, right, up, down. All right, so minus j, cross out the column and the row that j is in, and I get minus 2, 0, 3, 0, and then plus k, cross out the column and the row that k is in, and I get minus 2, 4, 3, 1/2. And then I go to evaluate this, and I'm going to get I. And then the way you evaluate a determinant is you go up from the upper left to the lower right, you go across 4 times 0, minus 1/2 times 0. And of course that's 0. Then minus j hat, minus 2 times 0, 3 times 0, that's just 0, plus k hat, minus 2 times 1/2 is negative 1, minus 3 times 4 is 12. And again, this is 0 and this is 0, so we'll ignore those. And I'm left with minus 13 k hat, which is a vector that points strictly in the z direction. Now that's important to notice also, because A is in the xy plane, and B is in the xy plane, and the only vector that would be mutually perpendicular would be something strictly in the z direction. In other words, if the xy plane is a tabletop, the only thing perpendicular to anything on the tabletop has to go up or down. In this case it goes down because of the negative sign. Now the second question was, what's the angle in between? Well, the magnitude of A is equal to the square root of minus 2 squared plus 4 squared. And so that's the square root of 4 plus 16, which is the square root of 20. And the magnitude of B is the square root of 3 squared plus 1/2 squared, which is the square root of 9.25. And so remember, the magnitude of A cross B is equal to the magnitude of A times the magnitude of B times the sine of the angle in between. But the magnitude of A cross B is just 13. So 13 equals the square root of 20 times the square root of 9.25 times the sine of alpha. So 13 divided by roughly 13.6 equals the sine of alpha. And so alpha equals the arc sine of 13 over 13.6. And I get 72.9 degrees. And if I drew that out, just to kind of give myself a check on that, so here's the xy axis. So I go over 2 and up 4. That's A. And then B was over 3 and up 1/2. And yeah, those are pretty decent size apart. And I'm actually looking at this angle. Now I haven't drawn this to scale, but I'm really wondering whether or not that's 72.9 or 180 minus 72.9. And the problem here is that if this angle is obtuse, i.e. if this angle is between 90 and 180 degrees, the arc sine is going to be positive in either case. So the dot product becomes important. So A dot B, let's do that, and this is equal to minus 2i plus 4j dotted with 3i plus a half j. And this is going to equal minus 2 times 3 a sub x times b sub x, no i's in there, no j's, plus 4 times a half. And so this is minus 6 plus 2, which is negative 4. But remember also that a dot b equals a times b times the cosine of alpha, and this is alpha in here. So minus 4 equals the magnitude of a, which was 20, the magnitude of b, which was 9.25, times the cosine of alpha. So the cosine of alpha equals negative 4 over the square root of 20 times the square root of 9.25, which is minus 4 over 13.6, and then the arc cosine of that will tell me alpha. So it's the arc cosine of minus 4 over 13.6, and that's 107.1 degrees. And so indeed the angle is obtuse, and if I go back to the previous page, we saw that alpha was 72.9, but 107.1 and 72.9 adds up to 180. And so in fact alpha is equal to 107.1. And really I know that because the cosine of alpha is negative, that means it has to be in the second quadrant or the fourth quadrant. And as I look at the diagram here, it's clearly in the second quadrant. So the cosine is really a better way of finding the angle between A and B. So we are better off using the dot product to find the angle than we are the cross product. Okay, here's another example. In this case now I have two three-dimensional vectors. So I want A cross B, and again I'm going to write this out in its determinant format. So I, J, K is always the top row. And then A, the first vector, is always the second row. And that's 3 minus 5, 2. And B is always the third row. So that's minus 2, 1, 7. And so this is going to be I. Cross out the column and the row that I is in. And I get minus 5, 2, 1, 7. Minus J hat, because it's the second term. Cross out the column and the row, and I'm left with 3, 2, minus 2, 7, right? This has not been crossed out, this has not been crossed out, plus K hat, the column and the row, 3 minus 5, minus 2, 1. And you could use the formula that I gave you earlier, but I like using the determinant method better. Heck, I can get my calculator to do it just as well. So I get I hat, and I get minus 35, subtract 2, minus J hat, 21, subtract negative 4. So minus and minus 4. Be careful of the signs. Plus K hat, 3, subtract positive 10. Because negative and negative is positive. So I get minus 37, I, minus, because of this minus here. And then 21 minus a minus 4 is 25, J, minus 7, K. So there's A cross B. Well, let's find the magnitude of A. That's going to equal the square root of 3 squared plus negative 5, quantity squared, plus 2 squared. And that's going to equal the square root of 9 plus 25 plus 4, which is the square root of 38. And the magnitude of B is the square root of negative 2 squared plus 1 squared plus 7 squared. And that's going to be the square root of 4 plus 1 plus 49, which is the square root of 54. And then the magnitude of A cross B equals the square root of negative 37 squared plus negative 25 squared plus negative 7 squared. And that's going to equal the square root of 1,369 plus the square root of 625 plus the square root of 49, which is the square root of 2,043. And so magnitude of A cross B equals the magnitude of A times the magnitude of B times the sine of alpha. And so that's the same as saying the square root of 2043 equals the square root of 38 times the square root of 54 times the sine of alpha. And so the sine of alpha equals the square root of 2043 over the square root of 38, the square root of 54, which is 0.97119. And so alpha is equal to 76.2 degrees. And again, it could be 180 minus 76.2. So let's find out by using the dot product. So A dot B equals 3I minus 5J plus 2K dotted with minus 2I plus J plus 7K. And that's going to equal 3 times negative 2 plus negative 5 times 1 plus 2 times 7, which is negative 6 minus 5 plus 14, which is 3. But A dot B also equals A B cosine alpha. So 3 equals A, which is the square root of 38, times B, which is the square root of 54, times the cosine of alpha. And so 3 over the square root of 38 over the square root of 54 equals the cosine of alpha. But 3 over that square root is 0.0662266. And so alpha is the arc cosine of that, and that's 86.2 degrees, which is not the same. So I've got an error someplace. Alright, so I checked my calculator, and my cross product is correct, and my dot product is correct, and the magnitude of B is correct, and the magnitude of A is correct, and the arc cosine is correct. The square root of 2043 is correct. There's my error. This should be 0.997. And now I get 86.2. So I have agreement here. All right, that should do it.